So, um, the absolute chaos of packing a car for a weekend road trip.
Oh yeah, trying to fit everything in without ruining everyone's mood.
Exactly. You are trying to perfectly balance the fuel economy, cramming in enough snacks so no one gets hangry, and figuring out the exact seating arrangement to preserve passenger sanity.
It is a really tricky equation.
It is. Well, we have prepared a custom deep dive just for you today, scaling that exact packing problem up to the ultimate road trip. We are expanding across the solar system.
Which is such an incredibly optimistic and exciting topic to explore.
It really is. The mission of our deep dive today into the sources is to explore this fascinating 2026 paper by NASA's Caleb Scharf. We are unpacking the brand new concept of the Interplanetary Habitable Zone, or IHZ.
And we were discovering exactly why humanity has hit the absolute cosmic jackpot.
Right, because you are probably familiar with the traditional habitable zone, that orbital Goldilocks area where water doesn't freeze or boil.
But that only really looks at where life can originate. What is fascinating here is how the IHD redefines our place in the universe.
Because it measures how well a planetary system can actually support a spacefaring species as it expands, right?
Precisely. It balances four crucial factors. You have solar power availability, radiation safety, material resources, and travel energy costs, which scientists call delta V.
Okay, let's unpack that for a second. Delta V basically means the actual physical effort and fuel required to hop from one orbit to another.
Yes, it is the literal toll you pay to travel the cosmic highway. If the gravity well is too deep or the distance is too far, the fuel cost just becomes a massive barrier.
Speaking of optimizing complex systems and maximizing resources, this podcast is sponsored by Embersilk.
A fantastic service.
Truly. Need help with AI training, automation, integration, or software development? Uncovering where AI agents could make the most impact for your business or personal life.
That is something everyone is looking at right now.
Definitely. You should check out embersilk.com for all your AI needs. So, zooming back out to the solar system.
Back to the massive scale of space.
Right. The paper mentions this agent-based computer simulation. How exactly does that show our neighborhood is primed for expansion?
Well, an agent-based simulation is essentially like playing a massive game of The Sims.
Okay, I love that analogy.
Yeah, you program virtual agents, in this case human settlers, give them specific behavioral rules based on economics and physics, and just see how they act over time.
And the simulation revealed that for a species to migrate, destinations need a resource lure.
A compelling reason to actually pack up the car and leave. The model proves that if the moon's resource value is recognized as just 50% higher than Earth's, a vibrant outward migration naturally begins.
Wait, why exactly 50%?
Yeah.
That seems highly specific.
Because of that delta V we just talked about,
Yeah.
it takes a tremendous amount of energy to escape Earth's gravity. The economic or survival return on investment on the moon has to be significantly higher to justify the massive cost of the trip.
Ah, that makes perfect sense.
Yeah.
So once that 50% threshold is met, humanity establishes a foothold on the moon.
Exactly. And from there, the moon's lower gravity makes it a perfect, cheap stepping stone to Mars and eventually the asteroid belt.
Which brings us to the sheer scale of the resources out there waiting for us. It is just staggering.
We have over 900,000 mapped asteroids sitting perfectly accessible between 1.5 and 4 astronomical units from the sun.
And just to visualize that scale for you, 1 astronomical unit is the distance from the Earth to the sun, about 93 million miles. So this massive treasure chest of resources is literally just next door in cosmic terms.
Right, and to highlight how incredibly lucky you and all of humanity are, the paper contrasts our solar system with the famous TRAPPIST-1 exoplanet system.
That is the one where all the planets are clustered really close together. You would think that would make space travel a total breeze.
You really would. But the star at the center of TRAPPIST-1 emits intense, high levels of radiation. To survive traveling between those closely packed planets, a civilization would need heavy shielding and readily available fuel.
And without a massive, easily accessible asteroid belt to mine those materials while in transit, the simulation shows their interplanetary expansion effectively stalls out.
Yes, they are trapped. But our specific layout, having the Earth, a helpful moon, Mars, and then a dense belt of easily mined rocks, is basically an incredible optimistic launch pad for our future.
Wow. We really are in the perfect position to explore the stars.
We really are, and it raises a thrilling idea to leave you with today.
Oh, I love a good provocative thought.
When we look at the stars, searching for alien life, maybe we shouldn't just be looking for a single habitable planet. Maybe we should be looking for the technosignatures of their interplanetary highways.
Like the infrared glow of mining operations or the massive infrastructures of a species that successfully navigated its own interplanetary habitable zone.
Exactly. Look for the cosmic road trips of other civilizations.
What an inspiring way to look at the night sky. If you enjoyed this podcast, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.